Okay, so let's start our analysis. So we will use a so-called monopoly pricing problem to illustrate the idea of information asymmetry or the two-type model. So what's the problem? Suppose that you are producing and sell one product in a particular region, and you are the only one who are able to sell this product in that region. Okay, and then your problem is how to price your product to maximize your profit. Of course, there may be multiple factors that affect the answer here, but let's consider the simplest case first. The case is that you know there is a demand function, okay? And that demand function is simply 1 minus p. So that's going to give you a problem to solve like this. You have a demand that depends on your price, and you have a price about that. You may have a production cost, but let's assume there is no cost there. So your problem is just like this, and immediately you can solve for the optimal price 1/2 and the related profit 1/4. So that's nothing special. But here, please observe the following thing. The demand function 1 minus p actually comes from two assumptions. First, we assume that a consumer's utility for buying that product is V minus P, and V is the consumer's valuation about that product. So what does that mean? Each consumer is going to, each consumer has a valuation about the product. Some may think the product deserves $1. Some may think the product deserves only $0.7. Okay, so that's the consumer's valuation. As long as the consumer's valuation is greater than the price, the consumer is going to buy it. So that's the basic assumption. And of course, we also make some assumptions about consumer's valuation distribution. Here we assume it is uniformly distributed within 0 and 1. So that means with equal probability, we see a realization within 0 and 1. So that's how we get the profit function. Right? Suppose this is P. Given each price P, according to this particular setting, we know the probability for the consumer to buy it is just 1 minus p, okay? And that goes to our demand function. So our demand function is somewhere like this. Okay, this is 1, this is 1. This is my demand function, Q of P. So where is the monopolist profit here? The monopolist sets the profit to sets the price to here, okay, 1/2, and correspondingly we have the quantity 1/2, okay, and the product or the area of this rectangle is just the seller's profit, okay. This is 1/4. If you happen to know something called the consumer's surplus from your economics course, then you know the consumer's surplus are here. The area of this triangle. So why is that? Here, these are the consumers who buy this product. These consumers, their valuation is higher than the price 1/2. So for those consumers whose valuation is within 1/2 and 1, they will buy the product. For each of them, the amount they get is V minus P. Okay, so the total gain or the total surplus earned by the consumers can be calculated like this. Okay, for each consumer, the valuation is V. For V between 1/2 and 1, they earn V minus P. Okay, and after you do this calculation, immediately you can see it's just 1 over 8. Okay, so it's just the area here. So this is the very basic analysis. There is really nothing special here. But then, after several days for you to run the business, there comes one guy. This guy tells you that some people are willing to pay more. They are willing to pay more than one half, right? But your price is too low. And also, some potential sales are lost. Some people are not willing to pay one half, but you are charging them too high. So he gave you a useless solution, a suggestion. You actually can ask all those consumers about how much they want to pay for this product and then charge them different prices. So he is suggesting you to charge multiple prices for different consumers. Immediately you know that's impossible. Okay, in this case that's impossible. We want to do price discrimination. This term basically means to charge different people different prices. However, when consumers' valuations are completely hidden to you, price discrimination is impossible. Okay? Because if you ask each consumer how much he is willing to pay, how do you like this product? No one is going to tell you that I want to pay $0.8. Your product is very good. I just like it. Please, no matter how high the product is, how high the price is, I am going to buy it. No one will say that. Everybody will say your product is ugly, your product is bad, your product is useless. I only want to pay $0.1 to buy it, something like that. So it is impossible for you to apply this strategy. And that's why information asymmetry creates some difficulty to you. If you can really see those valuations, you will be able to implement this strategy, and then you can earn a lot of money by doing the so-called perfect price discrimination, right? So to visualize it, suppose you really do perfect price discrimination. Let's see what's going to happen. Again, this is the graph, and this is your price. Your demand function is here. Suppose you do perfect price discrimination. That means here comes a consumer who is willing to pay $0.9. Then you will charge it $0.9 and he will buy the product. So you're going to earn this amount from the consumer. For those guys who are willing to pay 0.8, you will charge them 0.8, and so on and so on. So you will be able to sell the product to all the consumers at the price, at the highest price that they are willing to pay. So in total, you are going to earn 1 over 2. Okay, 1 over 2. This is greater than 1 over 4, which is the original profit that you may do without price discrimination. Previously, you only set one price and earn 1 over 4. Here, you are going to set multiple prices and earn 1 over 2. Okay, that's excellent. So immediately you can see, if you can see the consumer's types, you can earn more. If you are a principal and you can see the agent's type, you can earn more. That's typically the case. Okay, so information asymmetry. The presence of information asymmetry will create some inefficiencies. In this case, because there is information asymmetry, you only set the price to be 1/2, and therefore only 1/2 of the consumers earn a non-negative utility. Only 1/2 of the consumers buy this product. Only with probability 1/2, the trading can really happen. So that's inefficiency. However, information asymmetry is also going to protect the agent, right? Previously, the agent earned 1 over 8 as the consumer's surplus. Okay, consumer surplus. All the consumers together earn 1 over 8 as their utility. But now, they are only to get zero. They are only to get zero because no one is earning a positive utility. So this also confirms our intuition. Getting some private information helps the agent. Okay, helps the agent. Here, I want to highlight one thing. We used a few sections to tell you that decentralization will create inefficiency. That's of course true, but decentralization may not be the only reason. Here, in the two situations, either with complete information or with information asymmetry, the system is decentralized. Okay? In the two decentralized system, one is more efficient than the other. The one with complete information is more efficient than the one with information asymmetry. So, for the same decentralization system, information asymmetry may be the reason or may be the source of inefficiency. Okay? So, information is really an issue to consider in any decentralization system. So in general, no consumer is going to tell you his preferences. So let's consider the easiest case with valuation heterogeneity. And that's there are two kinds of consumers. So below I'm going to formulate the problem with two kinds of consumers. Let's do the following. Suppose consumers now want to buy the product. Okay, if the consumer buy if the consumer buys Q units, okay, then the positive utility term is theta times V of Q. Here, V of Q is a function that is strictly increasing and concave. So increasing and concave is just something like this. Okay, increasing and concave. So this basically means when your Q becomes higher, you're going to become happier, but the marginal utility will decrease. So this is very intuitive, right? If I buy one bottle of Coke, I'm happy. 2 bottles of Coke, I can still happy. I'm really happier, but the marginal benefit decreases. There is a type called theta. And theta, we say there may be two values, theta low and theta high, or theta L and theta H. Theta L is a smaller number. So that means if you have a higher type or a higher theta, then you prefer more products, or you are willing to pay more for those products. Here, the payment is denoted with the variable capital T. Okay, so that means I, as a consumer, pay $T to get Q units. Okay, that's the setting for consumers. Theta H and theta L are possible values of the consumer's type theta. And then we will say that a consumer is of a high type or type H if his type theta is theta H. Otherwise, it's low type or type L. Let's assume that the seller believes there is a probability beta for consumers to have a low type. So beta is of course something that is decided by the seller. The seller does not know how many consumers have a low type, but the seller can do some market research to do some estimations or so on and so on. And the seller somehow will have a belief about that probability. That's going to be denoted by beta. And we're going to assume that that's something constant. Finally, there is a unit production cost, C. So to produce each product, the manufacturer needs to pay C dollars. C is going to be assumed to be somewhat small so that it's reasonable to do business. So The seller has its utility function, which is T minus CQ. If I produce 10 units, I need to pay 10 times C as my cost. But I can collect some money from the buyers. So I'm going to have a profit like this. Okay? So now the problem is actually precise. As a seller, I want to price my products so that I can maximize my expected profit. Okay, I want to set price to my products, and consumers may buy multiple products, right? So I am allowed to set different prices for different units, for different number of units. For example, no one says I need to set a linear contract. I probably can do the following. For the first quantity, for the first unit, you need to pay $10. If you buy 2, it's $20. But if you buy 3, it's going to be 28. Okay? I am just saying that this is allowed because you are allowed to offer discount. Or if the product is very limited, you are allowed to charge more for additional units. So you are facing a pricing problem about how to price different quantities so that you can maximize your expected profit. So how may we do that? Suppose I have complete information. Then when a consumer comes into my store, I see is type H or type L. Suppose this guy is type H. Then I know what? I know I should solve this problem. I should try to sell him a certain quantity QH and charge him a certain price TH. Here, URS means unrestricted in sign, so that basically means TH can be positive or negative, but that doesn't matter. So when I choose these two numbers, there are something that I should know. First, when I say, okay, for these 5 units, please pay me $50, I need to make sure that that offer is good to the buyer. The buyer should be willing to buy this amount of product because he can get a non-negative utility. Okay, so if I plug in QH and TH into the buyer's utility function, that should be non-negative. Given that, I know for my offer, the agent, the consumer is going to accept my offer, and then I can earn TH minus CQH. So if I see a high type consumer, I do this. If I see a low type consumer, theta H is going to become theta L, and I'm going to solve a different problem. Okay, because I can see his type, so I can do that. According to different types of consumers, I'm going to solve different problems and make different offers. This problem can be easily solved. The first observation is that no matter what's your solution should have the constraint binding at your optimal solution. Binding basically means a constraint is binding at a solution means that constraint becomes an equality constraint. Okay, so that means if a solution is an optimal solution, it must make that constraint becomes equality. So why is that? Suppose you have an optimal solution which makes theta h times v of q minus t greater than 0. Okay, suppose you have a solution making your constraint strictly positive than 0. Then one thing you may do is to increase t a little bit. That's not going to violate the constraint, but that's going to increase your objective function a little bit, right? So your previous solution cannot be optimal. If a solution is optimal, it must make this exactly equal to 0. So if we have that in mind, we can actually replace TH by this guy. Okay, so we are actually solving this problem. Maximize theta h VQH minus CQH. And then we have that first order condition. Because this is just, basically we can treat this as an unconstrained problem. First order condition is going to tell us that the optimal quantity, let's call it Q tilde H, should be satisfying this equality. Okay, differentiate this with respect to QH and set it to 0. That's my first order condition. With that, and then my optimal transfer can be decided with this equality. That's how I may solve this problem. So this solution is not in a closed form because I don't really assign a function form for v, but I know given any function v, I can do this. So for type I know my solution is like this, right? No matter it is L or U. For different type, theta I has different value, so my solution will change a little bit, but I know how to do that. This will be called the first best solution. First best means the best thing you may want to do when you have complete information. Okay, that's first best. Basically, that's the best you may have when you have complete information. So that's an optimal solution which should satisfy something like this. And then we can see that the consumer is going to earn no surplus or no rent. We like to call them rent in this kind of situation. So what does that mean? For each consumer, he is going to get some quantity Q tilde I by paying T tilde I. And he will realize that by paying that amount to get that amount of units, his utility will be 0. He will be willing to do that, but he is earning nothing. Okay, he is really earning nothing. And that means the seller extracts all the rents from the consumer. Okay, so with complete information, we know how to solve that problem, and we can see the seller is really happy because the seller earns everything from the consumer. Just like the very simple example with all the triangular part goes to the manufacturer, right? So later we will tell you what's going to happen when there is information asymmetry, how to solve that problem and try to deliver some insights to you. Thank you.